Part 1. The Great Paradox of the Ocean. Imagine this. You're standing alone in the middle of the Pacific Ocean. Water surrounds you in every direction, endless, shimmering, infinite. Yet you are dying of thirst. It is the oldest cruelty of the sea. Water, water everywhere, nor any drop to drink. For most of history, being stranded at sea meant certain death. Seawater isn't just salty, it's lethal. With 3.5% dissolved salts, a single gulp begins a chain reaction your body cannot escape. Your kidneys fail, your cells dehydrate, and within days, the ocean that carried life becomes the ocean that ends it. But some sailors lived. Some WWII pilots survived long enough to be rescued. And they did it using a forgotten, low-tech marvel, something so simple you could build one in your backyard. No engines, no electronics, just heat, metal, and the basic laws of physics. In this journey, we uncover how ancient sailors, Arab alchemists, and modern survival engineers used thermal distillation to turn deadly seawater into drinkable life. We'll see why copper became the quiet hero of the process and learn the strange sailor's trick that keeps pure distilled water from harming the very people who depend on it. So ask yourself, how could a single flame and a piece of metal outsmart the entire ocean? Stay with us, because the answer is a story of ingenuity, survival, and the physics that kept sailors alive when the world around them was nothing but water. Part 2. The Ancient Roots of Purity. Desalination may sound like a sleek, modern buzzword, but its story reaches far deeper into human history, back to a time when the first civilizations were just beginning to understand the hidden rules of nature. Long before factories, laboratories, or digital sensors, ancient engineers were already confronting the same paradox we face today. The sea holds more water than any place on Earth, yet none of it can be drunk. And so, as early as 2000 BCE, in the sun-baked lands of Mesopotamia and Egypt, people began experimenting with one of humanity's earliest scientific breakthroughs, primitive distillation. By the 1st century BCE, the idea had traveled to Greece. Aristotle himself described how seawater could be purified simply by heating it and capturing its vapor. And centuries later, Arab alchemists like Jabir ibn Hayyan transformed this scattered knowledge into something far more refined. They created the alembic still, an elegant curved system of vessels that turned vapor into clean, life-saving droplets. These early pioneers didn't need equations or modern sensors to understand the truth. They observed something fundamental, something universal. Water behaves differently from salt. H2O molecules have a much higher vapor pressure, meaning they escape into the air long before minerals and impurities can follow. And that gap, this enormous difference between when water becomes vapor and when salt even begins to gasify at a staggering 1413 degrees Celsius, is what allows us to separate the good from the bad, the pure from the deadly. It is a law of physics so ancient and so trustworthy that even today, in the age of membrane filters, desalination plants, and chemical-heavy technologies, this simple principle remains undefeated in emergencies. Modern systems fail, batteries die, electronics corrode, but heat and phase change remain loyal to the people who understand them. This is the legacy that sailors inherited, a lineage of problem solvers who realized that the ocean could be defeated not by force, but by understanding its nature. And in their hands, the wisdom of the ancients became a lifeline, one that saved countless lives on waters where failure meant death. Part 3. The Anatomy of a Survival Still. If you had to build a life-saving desalination system today, one that could keep you alive on an empty horizon, what materials would you trust? Most people think of plastic bottles or improvised containers. But the true experts, the ones who understand the ocean's cruelty, reach for something very different: stainless steel and copper. because in the battle for drinkable water, your greatest ally is not luck, it is the right metal. Let's start with the heart of the system, the boiler. This is the engine of your survival still, the chamber that turns deadly seawater into rising, cleansing steam. But not just any pot can withstand the ocean. Most household cookware is made from grade 304 stainless steel. It looks sturdy until it meets concentrated boiling salt. Out at sea, salt becomes a silent predator. It corrodes, it pits, it eats through metal from the inside out. That's why seasoned sailors and survival engineers choose grade 316 stainless steel instead. Inside this metal lies a secret ingredient, 2 to 3% molybdenum, small in quantity but enormous in power. It creates a shield against chloride-induced pitting, the exact kind of corrosion that destroys ordinary steel. At temperatures approaching 800 degrees Celsius, where weaker metals crack or crumble, grade 316 remains loyal, intact, and battle-ready. But making steam is only half the story. To drink, you must condense it, and this is where copper steps out of the shadows and becomes king. Thermal conductivity, the ability of a material to move heat, is everything in a condenser. Stainless steel trudges along at 16 to 24 watts per meter Kelvin. But copper? Copper races ahead with a staggering 401. It moves heat 25 times faster, meaning steam becomes liquid almost the moment it touches the coil. This gives you a compact, efficient design, perfect for a small raft, a survival kit, or a desperate situation where every second and every drop matter. Yet copper doesn't just cool the steam, it purifies it. As vapor passes along its surface, copper helps strip out sulfur compounds that make water smell foul or taste metallic. In ancient alchemy, copper was respected for its cleansing energies. Today we simply call it chemistry, but the result is the same: cleaner, safer water. However, with copper comes one deadly warning. It is a detail so small that many overlook it until it's too late. Never, under any circumstances, use old plumbing solder. For generations, solder contained lead, a neurotoxin that leaches into water when heated. A few droplets may not kill you immediately, but in survival conditions, lead poisoning becomes a slow, merciless enemy. Modern standards require lead-free solder with less than 0.2% lead, and when joining copper to stainless steel, only specialized silver-rich alloys, often around 56% silver, can create a safe, durable bond. Acid flux then breaks through the oxide layer on steel, allowing the metals to fuse cleanly and without contamination. In survival, every choice you make matters. The oceans are unforgiving, but the tools we choose can tip the scales between despair and one more day of life. Part 4. Hacking the physics of heat. Now that you have your lifeline in the middle of an indifferent ocean, the next question becomes survival's oldest obsession: efficiency. Out here, fuel is more precious than gold. Every ember, every scrap of wood or fabric you burn must count. And so the real challenge begins: learning how to master heat itself. Many people make the same mistake. They believe that boiling water harder, faster, louder somehow makes the process better. It feels intuitive, but it is dangerously wrong. When seawater roars and tumbles inside a boiling vessel, it doesn't just produce steam, it throws tiny droplets of brine into the vapor path. These droplets ride the turbulence into the condenser. Sailors called this carryover, and it ruins everything. What should be pure, life-saving water becomes tainted once again with invisible salt. The ocean, it seems, always tries to sneak back in. The secret is calmness, a steady, controlled simmer, heat that rises like a quiet breath rather than a violent storm. Only then does the vapor remain clean, and only then does the still give you water you can trust. But boiling is only half the battle. Once water becomes steam, you must coax it back into liquid. And here, sailors turn to one of nature's oldest tricks: evaporative cooling. Imagine the copper coil of your still wrapped tightly in a cloth soaked with seawater. As the wind brushes across the fabric, the water in the cloth begins to evaporate, and with each molecule that escapes into the air, it steals heat away from the copper beneath. Slowly, steadily, the coil cools, and steam collapses into droplets. This simple method, just cloth and air, can raise your water output by nearly a third. No fans, no machines, just the quiet physics that kept sailors alive long before engines ruled the waves. And if you happen to have a bucket of cool water, your chances improve even more. Submerging the copper coil into what old mariners called a flake stand turns the entire bucket into a heat sponge. The cold mass absorbs energy far faster than air alone, forcing steam to condense instantly and giving you every last drop the ocean tried to deny you. This is the art of survival, understanding that even in the harshest places, nature offers tools, if you know how to look for them. Heat, water, air. Three simple elements that become the difference between dehydration and another sunrise. Part 5. The distilled water paradox. Now comes a twist in our story, one that surprises almost everyone who hears it for the first time. Because the very water that saves your life at sea can also harm you if you don't understand its true nature. Distilled water sounds perfect. It is pure, clean, and free of salt. But in survival, purity carries its own dangers. When water is freshly distilled, it becomes something scientists call demineralized. It lacks the electrolytes your body depends on, minerals like calcium, magnesium, potassium, and sodium. Without them, your cells cannot function, your nerves cannot fire, and your muscles begin to cramp and weaken. But the real danger is more subtle. Distilled water is chemically hungry. With no minerals of its own, it tries to pull them from whatever it touches. In plumbing, this corrodes pipes. In the human body, it pulls minerals from your bones, your teeth, your bloodstream. And over long periods, this can lead to deficiencies, exhaustion, and even heart complications. Yet sailors knew something most modern survival manuals forget. They understood that even life-saving water must be balanced. And so, they developed a skill that almost vanished from collective memory, a technique known today as survival remineralization. They didn't drink distilled water straight from the condenser. Instead, they added back a whisper of the ocean, a single drop of concentrated brine, the dark, salty residue left at the bottom of the boiling pot, mixed into 100 or even 200 parts distilled water. So little that the taste never changed, yet enough to restore the minerals their bodies desperately needed. This tiny adjustment transformed sterile, aggressive water into something closer to what the human body expects. It prevented hyponatremia, the condition where cells swell dangerously due to lack of sodium. It kept muscle function steady, nerve signals sharp, and energy levels stable in an environment that offered no mercy. In other words, even the ocean's deadliest water could become safe, not just through fire and metal, but through wisdom handed down from generations who lived or died by the smallest details. And that is the paradox. Distilled water can save you, but only knowledge keeps it from harming you. Part 6. Lessons from the sun, the solar still. But what happens when the fire goes out? When the last piece of driftwood is gone? When the night grows cold and the ocean offers no more fuel? For stranded sailors, this was not a hypothetical question. It was a terrifying reality. And yet, even in the moments when flame and metal could no longer help them, they had one final ally, one that rose every morning without fail: the sun. During World War II, thousands of life rafts carried a remarkable piece of survival equipment: the solar still. It looked simple, almost unimpressive: a basin, a clear cover, and a small collector cup. But behind its modest appearance was a profound lesson in physics and patience. The principle was ancient. The sun heats the water evaporates, the vapor rises, touches the clear plastic or glass sheet above, and condenses into droplets that slowly roll down into a waiting cup. It is the same cycle that paints clouds across the sky, the same process that feeds rivers and storms. Nature's blueprint captured in a small device floating on an endless ocean. To make it work efficiently, sailors knew they needed one critical trick. The bottom of the basin had to be painted matte black. That dark surface absorbs far more solar radiation, converting sunlight into heat, and heat into life-saving vapor. Without it, the process slows to a crawl. But with it, even weak sunlight becomes fuel. Solar distillation is slow, painfully slow. On a good day, a single still might produce 1/2 liter to 2 liters of water. Nowhere near enough to relax, but just enough to survive. And in survival, just enough is everything. But its true magic lies not in speed, but in freedom. The solar still asks for no fire, no wood, no fuel, no metal, no maintenance. You set it up once, and the universe does the rest. While you conserve strength, while you sleep, while you hope for rescue, the sun continues working tirelessly on your behalf. A passive system that never tires, never rusts, and never runs out of energy. A system that could be the quiet line between despair and one more sunrise. In the end, the solar still is not merely a tool. It is a reminder that even in the harshest corners of existence, survival belongs to those who learn to cooperate with nature rather than fight against it. Part 7. Modern applications and the final takeaway. So after crossing oceans of history, after walking beside ancient philosophers, Arab alchemists, shipwrecked sailors, and WWII survivors, what do we take with us into the modern world? The first lesson is simple yet profound. Know your materials. Copper is not just metal, it's a conductor of life, a bridge that turns vapor into hope. And grade 316 steel is not just an upgrade, it's the difference between a vessel that survives salt and a vessel that fails when you need it most. The second lesson reaches far beyond engineering. Balance matters. The purest water is not always the safest. Your body is a chemistry lab of electrified minerals and delicate equilibrium. Even in survival, perfection can be dangerous. A single drop of brine, just one, can restore what distilled water takes away. And the third lesson is the quiet engine behind every ancient invention. Efficiency is survival. You don't always need fire, force, or modern gadgets. Sometimes all you need is a damp cloth wrapped around a copper coil. Sometimes you need a basin painted black. Sometimes you simply need the sun. We live in a world of high-tech filters, expensive gadgets, and digital survival tools. But sailors, those engineers of desperation, remind us that the laws of thermodynamics have never failed humanity. Fire, vapor, condensation. These forces existed long before electricity, and they will outlive every battery we build. Whether you're a prepper preparing for uncertain times, a hiker who loves the wild, an engineer fascinated by the elegance of simple machines, or just someone who respects the wisdom of the past, there is power in understanding heat and phase change. These are not just scientific principles, they are the oldest survival skills humans ever learned. So now the question comes to you. In our world of high-tech gear and endless innovation, which survival skill truly matters most? Is it the new tools we build, or the forgotten physics that carried our ancestors through storms, shipwrecks, and endless seas? Share your thoughts below, because the conversation you start may be the knowledge someone else relies on. And if this deep dive into humanity's forgotten desalination method sparked something in you, curiosity, respect, or a hunger to learn more, don't forget to like this video and subscribe to Historia Prime. Our mission is simple: to bring the wisdom of the past back to life, one story at a time. Stay curious, stay prepared, and as always, keep exploring. I'll see you in the next one.